All right, let's now start with our usual reminders. Okay, so your written test number 1 will be tomorrow. And then make sure you only go to the session you're officially enrolled in. We are fully packed for the 2 sections. If you don't go to the session you enrolled, you don't have a seat. All right, we'll take attendance tomorrow. Later today, I will send you some reminders about the rules that you can please follow and just make sure it's going to be smooth for everybody. And the review session from yesterday, if you want to see its material, it's on the lecture site already. Just go there and refresh your browser, make sure. Right? Your lab number 1 will be due this Friday. I know you're very busy learning about this material for written test number 1. However, after lab number 1 is due, I'm going to give you the solution, but I only got about a few days left before next Wednesday, which will be your programming test number 1. So you may want to do this at the same time. You definitely want to make good progress on this. All right? And then for those of you who actually attended the mock-up programming test on Friday, I'll try to give you some feedback. I will reach out to you about how you can check it. Okay? But I'll also make the starter projects and some additional grading tests available on the e-class already this morning. Once you have attempted yourself, you can also try the grading test to see how thoroughly correct your submission is. And I would say don't really wait for my solution, which I'll do maybe sometime on Friday. You really don't want to wait on that. You're going to know how to do it on your own. Know where you struggle and reach out for help. That'll be the best for your learning. Any question about what's going to happen? Okay, let's now do a very quick recap. I do have some fresh pages to do some recap for us about exceptions. So last time, we spoke about caller versus callee, and make sure you're very clear about the distinction between them. We keep emphasizing, about keep using these terminology. Make sure you use them also correctly. And we talk about how you can form a call stack based on the method calls that are in your pieces of code over here. Guys, please try to minimize talking here. It's not only distracting to me, but also to your classmate. They want to concentrate. You'll be much appreciated. You might think you're not loud enough. It's actually pretty loud. All right, much appreciated. All right, so we got a method call over here, and we can build a call stack accordingly. All right, so you want to make sure you know how to do it. And we talk about this annotation here, and we discuss the various options each level of the caller or callee is facing. The so-called catch or specify requirements, which I'm going to repeat again, maybe from a slightly different angle, so you can really get some full understanding out of it, hopefully. And we talk about the floats, either normal float or abnormal float. I'll also review that in just a moment. And we talk about version number 1 of this particular example. Right? And we're going to build on top of that to see how version 2 and 3 can illustrate different level in the call stack where the callee or the caller is trying to handle the exception. That's something we'll see. The same example, but different flavor about handling the exception. Any question from last time about the material? Any part you don't think that's clear? You want me to repeat? Yes, go ahead.
When you say specify, are you talking about the
That's correct. So when we say catch or specify requirements, either you say as part of the method header to say throws exception, that'll be specified. Catch option will be you say try catch block. Right? I'm glad you asked. That's a nice review. All right, let's now take a look. Yes.
Implementations where the main method throws some exception.
It's a very good question as well. The question was, in some cases, is it possible to main method, let's say the bottom of the stack, simply throws the exception? It's possible. But I would say that should be very, very unacceptable. Because in that way, you basically throw the exception back to the user on the console, which I'm going to illustrate today. Right? Of course, if you really can justify that particular programming decision for your application, by all means, go for it. That's allowed in Java. But always, there's any decision you make, you want to justify it. Okay? So I'm going to show you today. Don't worry. All right, let's move on. Any point you don't think that's clear? Today, the plan is really to finish off the discussion about exception. Any point you want me to slow down, interrupt. All right? Okay, number one, I would like to talk about, so I'm not going to talk about catch with specified requirements. I'm going to summarize in from two angles. One will be about the execution flow. The other one would be slightly more abstract, but I believe it's very precise, which would be from call stack. Let's do one thing at a time. Execution flow. Let's say we got the same method call over here, O.m. And let's say that part of the API of n tells you that it might throw the exception. That means it say throws a particular exception. All right? So there are two cases now. Either the exception is triggered from here, or the exception is not triggered, right? In this case, it will be triggered. This will be not triggered. That's why I say normal versus abnormal. Let's now take a look. So in the normal case, when we make the method call, it does not trigger the exception. Let's make that clear. Let's say the exception occurred. Sorry, beg your pardon, does not occur. That means conceptually there's no error in this method call. On the other hand, for the second case over here, it would be the exception does occur. This will be occurred. Right, two cases, the same method call. What we need to now understand will be the execution flow, about which lines of the execution, which lines of the code fragment is going to be executed. Let's now start with the left-hand side, the normal one. We definitely have to execute a method call. That'll be number one. And then let's say the exception does not occur, so there's no error. In which case, we're just going to continue with the rest of the try block until the end. Right? Let's say there's only one method there that might throw the exception. And then the remaining part about the catch block, it will be bypassed. They're not going to be executed. All right? That's case number one. Hey guys, please, at the end. Thank you, much appreciated. And then let's now take a look at the second case. So we got line number one here. And then let's say the exception does occur. In that case, we do have an error. So that would be the case where the execution flow got disrupted. So we don't really have the rest of the try block executed. So this part will be bypassed. So what is going to happen is we're going to execute a catch block with the matching exception, and then the remaining part of the catch block. Right? So you want to be very clear about when the exception either does not occur or occurs. What's going to be the consequence of the execution flow? And there's one more part which I didn't mention in both cases. What about outside the catch block? Let's say we got more code to be executed. So in both cases, they will be executed. Even if exception did occur over here, in that case, the catch block is going to handle in the proper way, presumably. So outside the catch block, outside this try and catch, these lines of code should still be executed no matter what. They are not really part of the try and catch. So now in the normal case, I will put this as number 3. And in the abnormal case, I'll put this as number 4, right? So you can see exactly the order. Any question about this? Yeah, it's more like a repetition from last time, but I'm just trying to number them rather than highlighting them. So a little bit different. All right, if no question here, so let me now move on to the second summary here. So this one is going to summarize precisely the catch with specified requirements. It's going to be a little bit mathematical, but it's not too bad. Quite a bit of symbols to look at, but it's very not difficult. Don't be terrified by the symbol. So once we summarize over here, I'm going to show you the concrete example by building more versions of the to handle or not to handle example. Okay, we'll worry about these questions one by one, but let's look at the stack over here. Caller, callee, the class name, method name, right? I just numbered them from 1 up to n. So we got n method calls in the stack, right? That should be easy to observe. I could have gone from C0 all the way to Cn minus 1. Like an array notation, but C1 to Cn should be good. So there are n method calls. All right, let's make the following assumption. Let's say on the top of the method call over here, this is where some exception is thrown. This is the origin of the exception. the origin of some exception. So question number 1, origin of exception, let's assume is simply C1.M1. All right? And symmetrically, you can see that over here, this will be the entry point of execution. So this one could be, for example, tester.main, right? This will be entry point of execution. That'll be the first one that was invoked, but there'll be last one finished, right? We talked about those observations last time. And once the exception is already thrown, this will be the first method that's going to be subject to the catch or specify requirements. And we said that usually, typically, this method here should just specify it, right? You would say throws that exception, right? You can think about this is the first method subject to the catch or specify requirements. But typically, we just specify it. That's the very first one. Now, we want to know from C1 all the way to the bottom Cn, how long should the catch or specify requirements be reinforced? How long? To what extent should it be reinforced? So there should be some point in the middle where the exception got first handled. So that will be what I call the breaking point. Okay? Let's say this. I'm going to sketch a little bit and see any one of you can give me some answer. Let's say this one here. This is one of the methods in the middle, Ci. If I tell you that this method here is a cutting point where all the methods underneath it are no longer subject to the catch or specify requirements, whereas all the methods above it have been subject to the catch or specify requirements. So what's really special about this particular cutting point? Anybody? Go ahead. What's so special? Okay, you said it handles the exception. I agree, but it's not exactly complete. What about methods above it? Was there any methods above it handle it?
No, they have to classify.
Exactly. So that should be the first one that handles that. Yes. All right. So let's say this is the cutting point. So think about this one over here. This may be the first method choosing to catch. All the colleagues or indirect colleagues above it, they have chosen to specify it, which means they simply propagate the exception. All right? So you can think about all these over here, including the cutting point itself over here. So these are, let me draw a little bit better. All these methods, including the cutting point method, these are the methods subject to the catch or specify requirements. All these, from C1 all the way to including Ci. But only from C1 all the way to the one before Ci, which is Ci minus 1, right? Ci minus 1 and I minus 1. All these will be, they are subject to the requirements, but they chose to specify it. And once we have found this particular breaking point, all the methods underneath it, all the way down to the main method, the entry point, they will no longer be subject to the requirements. Here. All these methods here, not subject to the catch or specify requirements. All right, let's be clear about this conceptual sketch over here. Right? In general, you just have n methods there on your call stack. N can be one, can be more than one. At some point in the call stack, there should be a counting point such that it is the first method counting from the top of the stack that handles the exception. That's the first one. All the methods above it have chosen to specify it. All the methods underneath it will no longer be subject to the catch with specified requirements. And we're going to see that some demonstration when I get back to the example. Yes, question?
What's the best practice in Java or OOP programming?
About like how deep you should really go?
Yeah.
Okay, very good question. The question was, what would be the best practice to say, why would I choose, for example, this one here rather than the one above it or the one underneath it, right? Where? I would say it's a design decision that will be up to the individual developer to decide. It will be not exactly within the scope of this course. I would say the general principle will be whenever you're designing your methods in your class, you want to think about where is the method that's supposed to handle this kind of error. What we're going to see maybe later, we're going to have like a circle and circle calculator. Let's say somehow if you got some negative radius passed to the circle for calculating the area, should the error be handled in the circle class or circle calculator? You got to make a decision. So I would say whatever decision you make, they're all going to work programmatically, but you got to justify the decision. No right or wrong. But for the purpose for today, I'm just helping you to understand if you choose like a different part of the call stack to be the cutting point, what will be the consequence? That's something we got to understand. Yeah. Yes?
So I just want to clarify. So if the first method call is
Yep.
an exception has occurred, and typically you specify with it.
Yes.
Doesn't that, my understanding of an exception is that it's like an error, so the code just stops working after that, and then it just like exits out. So how could they
Not handle that right away, right?
specify? Doesn't that mean that
Yeah.
there's a potential for it to be able to capture right
Yes.
away? Is that the right catch?
Yes. So thinking this way. So exceptions, you're right, is like an error. Another way to look at it would be you're receiving some input that's invalid, right? Typically, when you are designing your methods, input, you can categorize them into input and also output. All right, I beg your pardon, what I'm talking about. Valid input and valid output. Valid input and also invalid input. Right? So this will be some normal. And this will be exceptional. Right? It's really about input. That's the emphasis over here, right? So in the case of your methods has to be able to handle both, valid and invalid. That's called robustness. So whenever you hear people about, is your software robustness, is your software robust? That means is your program able to handle both valid and invalid input, right? That's an aside. Now, let's get back to here. Let's say I'm calling C1, let's say here, and then here I'm calling O dot, let's say in the context of N1, I'm calling a method here, that's an O dot N2, let's say, okay? Let's say somehow I'm passing some input over here, I, such that it should really trigger some exception into M2. Think more in this context. It should be somehow the responsibility of the caller that actually pass an invalid input into the callee. So it should be the caller here, at least from this level here, to handle the error. That will be the earliest timing. If you say, I give you the wrong input, but I'm expecting you to handle the error right away. Right? It's more or less like what usually will go as a rationale for why we are letting this method here, the callee, to simply throws the error, maybe to give some feedback back to the caller over here, and let the caller at least try to do something about it. And the caller might say, well, I'm not sure. The input I'm passing to you, I got passed by somebody else. Let me propagate it further. Right? That goes like this. So, recap. Typically, the method that throws the exception, they are simply usually pass the input passively. In that way, in normal cases, in most of the cases, you will just expect maybe the caller itself to handle the error the earliest, maybe not the caller itself.
So when we think of it like the caller would be like the manager and you have an employee, and they're giving like defective equipment, so technically it's like
make whatever analogy you like. I'm just saying, so programmatically, of course, you can still try to do the try and catch in where the exception is originated. You can try that in Java. It's also going to work. So what I'm talking about typically, right? That's just like, I'm just trying to explain to you what's the intuition behind the typical cases. Yeah. All right. Good question. I think there are so many things over here. We have to make a decision which can be justified to be right or wrong sometimes, but there will be some stuff that we have to do in a particular way in programming. I think what you asked about, whether this one here, should it be handled right here or maybe propagated further, is more like a design decision. Okay? Good. All right, if no further question, let's now answer some question quickly. Okay, Q2, the method subject to the catch with specified requirement, it should be all these methods here, including the cutting point. So that would be from C1 M1 all the way to CI dot MI. What about methods that are free from the requirement? It will be below, excluding the cutting point, right? Which would be CI plus 1 dot MI plus 1, right? What about, let's talk about two extreme cases, okay? Again, there's no right or wrong. I'm just talking to you about extreme cases. Extreme case number one. Let's say the exception is handled at the earliest possible timing. I said typically not here, right? That's where the exception is originated. So what will be the earliest timing? It should be its immediate caller. That will be the earliest timing. So that means once you pass the exception to here, it's already handled. That will be the cutting point. Only these two were subject to catch with specified requirements. Everything underneath would be free. Right? That's one extreme case. So here you can say this one here. So it's actually handled in C2.N2, meaning that C3.N3 all the way to Cn.Nn will be free from the catch with specified requirements. All right, extreme case number two, the other way. What if the exception is never handled? Let's say I propagate to you, all the way to here. The last point, like a main method. I still don't want to handle it. So it'll be propagated just to the console, which I'll show to you. So this one will be C1.M1 all the way to Cn.Mn. They are all subject to the catch word specified requirements, but they all chose to specify it. The consequence of that is the exception will eventually be thrown to the console, to the user. And you will see how bad it is. I'll illustrate to you. Question?
You said for the earliest example where it can be handled as C2.
C2 typically. Of course, it can be C1 if you really want to do it. I'll say typically the case. Yeah, I can see the lack of precision there, me, okay? I'll say programmatically, if you really want to handle the earliest, here, but that's not typical. I'll say typically, the earliest timing will be this one here. In case you got asked about this kind of question in the test or exam, I'll be very, very clear about, am I talking about typical or maybe programmatically, okay? All right, any question about this? Yes?
If it's still choose to not explicitly use the throws statement, it's still thrown to the console, right? Same as question 5?
Okay. Sorry, can you say that again?
If you still choose not to explicitly throw the exception, it still passes to the console, right? Same as if you
No, you have to. Let's say, for example, let's say all these methods chose to specify it, right? Now I'm facing, again, the catch was specified. I have to either do the try and catch block or I have to throw it as part of the header. If you do neither, you're going to get a compilation error. That's something we'll see. Okay, good. Just remember, whenever we talk about the methods that are subject to the requirement, what does it really mean to subject to the requirement? That means you have to choose either catch was specified. If you do neither, you cannot even compile your project. All right. Let's now move on to the handle or not to handle example. Right? Let's have a very quick review on what we did last Thursday about version number 1. Okay, if you remind yourself quickly, we got 3 classes in the call stack. We got A, we got B, we got tester. All right? So the tester, let's remind ourselves very quickly. So let's say this is the call. Oh, actually, we got call stack exactly here. Forgot about it. Let's say we got tester the main over here. That one there calls the b.mb. So that's why you can see method call, and then b.mb. And then b.mb over here calls a.ma. So that's why you see this arrow over here. A.ma is where the exception might be thrown if the input here is simply negative, right? So version number 1 does 2 things. Number 1, in the origin for the exception, we do the typical case. It simply propagates, specify. And then for B here, it will simply catch it. What does that mean? So this will be the breaking point. Agree? All right. So I'm going to explain a little bit further, which I didn't last Thursday. Up to this point here, this b.mb is the first method choosing to catch. That means this method here is no longer subject to the catch was specified requirements. No longer subject to, or we can say free from, to the catch word specify requirements. How do we see that? Let's now remind ourselves. If you go back to the code on the Eclipse, and by the way, the code has been made available to you on the lecture site. Really encourage you to try it out to really convince yourself. Let's now go back to version number 1. We'll develop version number 2 in just one moment. So we got class A over here. You can see A is where the exception might be thrown, and B over here is where we do the try and catch. You can see here B has already chosen to handle the exception. That means its caller is no longer subject to it. What does that mean? That means it will still compile if you simply call the method without either specifying it or catching it. Let's see. If you go to the tester class, you can see here, I'm simply calling ob.mb. I did not have any try and catch statement, or I did not have any throws exception besides the method header. I didn't do anything, but it still compiles. It compiles because of this remark I just made. Because this method here is no longer subject to the catch with specified requirements. Right? That's exactly what you want to review. Let's now try to play with this example a little bit just to strengthen our understanding. Version number 2. We still got A, B tester. Let's say this. A doesn't change. Origin of the exception. Propagate to here. B here, rather than choosing to catch the exception, is going to specify it. Meaning that it's going to propagate it to here. Now what does that mean? That means this method here will now be subject to the catch with specified requirement because it has not been handled just yet. All right? Let's now make some conceptual confirmation, and then we're going to illustrate it or prove it by using Eclipse. Since its callee, which is b.mb, has not handled it or has not caught it, the exception. Tester.main is still subject to the catch or specify requirements. Meaning that if you choose not to specify or not to catch, you're going to have some compilation error. We're going to see that. All right? Let's now verify this version number 2. And I would suggest we don't really develop from scratch. This is how I would suggest to make it very explicit about what changes. You can click on the package, Control-C, copy it, Control-V to paste it, right? We're going to duplicate it. Let's call that version number 2. Oh, let me do it again. Copy it and paste it. So version number 2. There we go. Version number 2 is a complete duplicate, right? So now we're going to do something on B. Rather than catching it, we're going to specify it. That's a change. Get rid of this. Get rid of the whole catch block. And let me fix the indentation. And that'll be it. Now we got line number 7 complaining the exception is not handled. So we have to make a commitment to the other option, right? Rather than catching it, we're going to specify it. And make sure when you say throws, make sure it's besides the method, not besides the class. All right? Throws, negative value exception. And make sure you import it from the right package. All right? So now as far as class B is concerned, we are okay because we opted for one option. But we're not in trouble in the tester. We are calling in line number 6 and 7, ob.mb. Because it chooses to specify it, so now it's the caller tested domain is also subject to catch with specify requirements, right? So now what should we do? We should either catch or specify. Let's say we catch in this case. Since b.mb specifies the exception, tester.main, its caller is still subject to the catch or specify requirements. All right. So what we can do is wrap it around a try and catch block, right? I'm going to say try, and we can catch the potential negative value exception. Let's now do that quickly. And you can do something here, right? I'm going to omit that. Maybe value exception here. And then I'm going to put it here. All right. Now, no compilation error. Right? So what this will make sure is if the exception really occurred from either line number 11 or line number 12, most likely line number 12, then it's going to be handled at this level. That will be it. Okay? That is version number 2. What about version number 3? Version number 3, we're going to make another slight modification. Now, this time, we're going to do the following. The origin of the exception, specify, and then now, between catch and specify, we now try to specify again. We tried nowhere to really catch the exception. That's also allowed to do in Java, but it's very bad practice. Let's now take a look. So if I go back, you know what? All I can say would be, think about all these methods, none of them choose to catch it. All choose to specify. All methods subject to the catch or specify requirements and all opt to specify. All right, let's see what's going to happen. All right. So I'm going to make a duplicate of version number 2. I'm going to make it version number 3, right? Copy it and paste it. And let's call that version _3. And then let's see. No change on A, and also no change on B, the same. But now for the last clause, tester, at the bottom of the stack. Rather than try and catch, let's say, let me get rid of this first. Right now it complains because I haven't handled either catch or specify. Let me specify it. So now make sure you do in between the main method and the curly bracket here. So you're going to say throws negative value exception. version number 3. And now we're back to compilation success again, right? And for this particular one, I'm going to show you how the code is going to run. But for the previous 2 versions, you should really play with the code. That's something you'll be expected to do, right? Just to see how things will work, execution flow-wise. Let's see what's going to happen here. We know that this line over here is not going to trigger any exception, but the last line over here would, right? Minus 46 is going to trigger. Exception basically is going to go like this. Minus 46 is going to trigger an exception from here, and then it's going to be propagated to b.mb. We choose to specify it, so it'll be propagated. This one here also choose to specify, so it'll be thrown to the console. Let's see. I'll just right-click on the class and run as Java application. Okay, watch what's going to happen at the bottom there. Right, there we go. All right, this is what I meant by nobody in the call stack took the responsibility for handling the exception. So who should really take it? Us, the user. So this is possible from Java programming, but it's a bad practice. You should never try to let your user be thrown some exception to their console. That's not acceptable. How would they know how to deal with it, right? Yes?
For a couple of the methods, you mentioned that we put the row exception specifically in the method and not in the class.
Mm-hmm.
Why?
Mm.
Wouldn't when you put it in the class, wouldn't that just make all the methods in that class?
Are you talking about this one here?
No, like when we, like above, like the void method.
Over here?
Yeah, we throw negative value exception. Why
Yes.
can't we put that in the class A line?
I didn't put it in the class. It's within the method, right? It's part of the method.
I'm asking, like, could we put it?
No, you cannot. If you you're asking, can we say throws over here rather than here? Put it here, right?
Yeah.
Let's try. I can tell you, you cannot. Good question. If I try that, error. Java doesn't even conform to Java syntax because after, I can tell you normally, after a class declaration, you will expect to see something like extends or implements, but that's something to do with inheritance or interface, but not throws an exception. You wouldn't say a class throws an exception. What does it really mean? Which method throws exception? It should be declared at the method level, not a class level. Answer your question?
Yeah.
Okay. I'm glad you asked, so everybody will know. All right, any other question about these 3 versions for this example here? Yes?
Yeah, so I was just trying it out. So when I extend the exception class.
I would say let's not talk about extension right now. That would be too confusing to talk about.
Right, but okay, fine. Then. When I just throw and say an illegal argument exception,
Let's only go with the customized exception for now, because illegal argument exception or maybe a null pointer exception, those other types, I would say let's keep them away just for now.
Okay.
Yeah, let's have the discussion more focused for now, please. Okay, yep. Yeah, for lab number 2, which you're going to release after Friday deadline, 12 noon. So you're going to see how you can build your own type of exception. So whenever you see a new type of exception, do it the way that I showed to you how to automatically generate it. But for other exception that your class may mention, that's something we can address later to avoid confusion. They do require some knowledge from the inheritance, which is not appropriate to talk about right now. Okay. Too early to talk about. Okay, so let me just see if anything missed on the slides. And for this one here, let me just undo, and then I'm going to make the source code available to you today. And then you can definitely play with them. All right? Okay, let's go back to the slides. Okay. All right, so that's version 1. Yeah, that's what we assume. We got version 1, version 2, version 3. And then version 1 here, we spoke about it. And version 2, version 3, they have been all discussed. You just have to watch out for how the call stack is going to be represented differently, right? Depending on which case we are talking about. It's really about where the cutting point is for the catch with specified requirements. And let's now talk about some more examples so we can see some concrete classes. And rather than going through Eclipse for each one of them, I'm going to show to you some manual tracing on the paper, and that should really make sense because we have seen quite a lot so far. Got 2 examples here. Let's go over one by one. Okay. All right, so example number 1 here, let's talk about circle. All right. So we have a circle class, and then we got some attribute called radius, and then we got some constructor, just default, which is okay. And then we got some mutator, which will be set radius, so some double value, right? So radius will be a double value, fractional. If the radius we are trying to set is strictly less than 0, we're going to throw some new exception, invalid radius exception, right? The code is here, but you can generate it by E-class. Sorry, not E-class, Eclipse, if you want to. And then otherwise, the radius is larger than or equal to 0. In that case, we'll set the radius accordingly. And you also got some accessor here, which is going to calculate the area using the formula, which I'm pretty sure you know about, right? Simple class. So whenever a caller calling this circle.setRadius method, they should be subject to catch or specify requirements because this method here, which is the origin of the exception, they did not opt for catching it. They only specify it as part of the method header. So that's why any caller of this method here should be subject to, right? That's something we can annotate as well. Caller of this method should be subject to catch or specify requirements. All right, we don't need this table because we're going to see the call stack. Okay, let's see how the other class is going to work. Pretty straightforward. So what we have is we got circle calculator number 1, and then we got the main method. This will be the entry point of execution. So we got circle calculator number 1 dot main. All right, and then inside we're actually going to call circle dot set radius. So circle dot set radius. Very simple call stack, only 2 methods there. Okay, and then here I am leaving that as blank, but we're going to see exactly what's going to happen. Okay, I'm going to try 2 test cases with you. I'm going to run them side by side for you to see exactly how the execution flow is going to go like. 10 versus -5. All right, we're going to see that. Here we just once we set a radius, and then we got to call the get area, and then going to print out the area. If the exception actually occur from this line here, right, which is because we specify it, in that case, we're going to do something here. So one very typical way to do things, it will be you simply print out the exception object, which is going to show you some useful information about the exception. You can try and see what's going to be printed out. Let's now do 2 passes of tracing. Pass number 1, we try 10. Pass number 2, we try -5. All right, for each one of them, we're going to number the execution flow. All right. First pass, 10. We start with this, number 1, and we're going to go into the try block, and then we're going to try to set the radius to be 10. All good. Let's say we step into the set radius method, right? We talk about how to build a call stack, right? You can try that as well. It was discussed last Tuesday or Thursday, either way. But let's say we step into set radius. Set radius over here. So number 4, we're going to check to see if the if is going to be true, because now it's 10. So 10 less than 0 should be false. So we go to the else part. So this will be number 5. And then number 6 will be to set the radius. So radius will be set to be 10. And After this, the execution of the set radius method will be terminated, will be done. So that means it will be removed from the stack, right? And we're going to resume the execution to the next line. No exception has been thrown in this case. So what's going to happen is number 7 over here, because at this point we know that the area is going to be calculated based on the radius being 10. And then number 8. Basically, we go until the rest of the try block is finished. Now, what else? Do we go into the catch block? Not really, right? Because this part here, it would just be bypassed. Okay, if you got any more code outside the catch block, I can put 9 over here, meaning that if you got more code underneath the catch block, they will be executed as well. That will be the execution sequence for normal case. Any question? So the next round, we're going to do another pass. We want to see what if the input here is -5, right? Let's try. We still start with creating circle object. That one's the same. We still go to the try block, and we are reaching the method call, number 3. Up to here, the same. And we're going to step into set radius the second time. So the same method here. And then we're going to say number 4 as well. But this time, R is -5. -5 less than 0, true. So number 5 is going to be here. We're going to throw that exception from this method, meaning that from this line over here, there will be an exception thrown. The rest of the try block is going to be bypassed. And we're going to go to the catch block over here. So that will be, let's continue from number 6. Number 6 will be the catch block. Number 7 will be this line over here. Right? And after executing 7, the entire try and catch block is done. So if there's any line that's listed after the try and catch block, it might still execute it. So that will be 8. Right, so it's a very straightforward comparison over here. You want to know exactly how the execution flow might be either go as normal or got disrupted by exception. Any question here? Any part that's not clear? Okay. And using this kind of interruption, like a disruption of the execution flow, that's something we'll have to make use again, maybe on Thursday when we introduce something about testing for errors, but that's something will go. What you really have to remember is execution flow. This one here, if no exception, continue. If exception disrupted, go to the catch block. Whatever is outside the catch block, you will execute it no matter what. All right, so that's the circles. The second version of here I want to show to you, the extension, I try to extend this example here a little bit. Because here, every time you change a new value over here, you will have to basically rerun the class as a Java application, right? It may not be that convenient because if I really give you -5, for example, you're going to see some printout of the error, but the user has no chance to really retry the input. So a better interaction should go like this. Let me show to you. If you go to the slides, that shows you some example output that we would like to have. That should be here. All right, so this is the version that we spoke about, version number 1. For version number 2, that's something we would like to see. So if you look at that, let's say we want to say prompt the user for some radius. If they enter -5, which somehow is going to trigger the exception. But we want your program to be so robust such that it's going to say, well, if you keep entering non-positive value back to me, I'm going to keep asking you for a valid value. Until you enter the very first positive value over here, I'm going to accept it and calculate the area. That's something I would like to extend the program into. That will be version number 2. So what we need is a while loop or for loop, either way. right? The two loops are equivalent. So now how do we write this one here, right? I'm going to show you the one solution directly. We're going to use some Boolean variable without any break or continue. So people usually criticize about using break or continue as resulting in something called spaghetti code in your code structure, which is not recommended. That would be another subject, maybe for design. For now, I'm going to show you the one good practice just using Boolean variable to control. Okay, let's now take a look. Okay, let me just go back to iPad over here. Okay, this one here. Second version. Okay, so the circle clause is just the same, no change. Okay, and what I want to do is, in the circle calculator, I call it number 2. And we still have the main method. But now this time we have a scanner, right? We use it backing a left 0. And we're going to somehow read the input from the user and then store that into R. And then we're going to use that R value to call set radius, right? So you can see that R and R. Whatever it is read from the user, use it as a radius. The idea would be if the R happen to be negative, then we should somehow let the user enter again. If the value user enter happen to be positive, we'll say, let's now calculate the area and give them the result. And there is a Boolean variable here called input radius is valid. I'll let you think about why the initial value should be false over here, but there's a negation here as part of the condition while. This was set up nicely, but I'm going to show you how that can be run. Okay, let's try to run it together. Let's now try the input here, let's say -5. That would be the first try from the user. Okay? So we're going to say, no, we're going to get a scanner, we're going to get a Boolean variable. Okay? Initially it's false, right? Just remember that. And then we're going to get 3. And false negation will be true. So that means we go into the while loop. And then number 4, we try to print out something to prompt the user. And then we're going to read something from the user. Let's say for this one here, it's going to set R to be -5. Okay, that's the first test. And then number 6, we're going to create a circle and then go to the try block. And then we're going to call this method here, c.setRadius. That one there is going to be -5 right now, right? Let's now step into the set radius, which will be here. And then it's going to be number 9. So R is right now -5. -5 less than 0, true. So number 10 would be we want to throw that exception. The remaining part, the else is of course bypassed. What will be 11 here? Because after this, we're going to resume to this method here. Should we go to here or should we go to the catch? Catch. Thank you. Obviously, because this exception here is thrown. So what we should do is 11. Go to the catch, and then we're going to print out something. This one is going to tell the user to try again. Okay so far? Okay. So now after this one here, basically there is nothing else beyond the catch block. So we are reaching the end of this current iteration for the while loop. So we'll basically go back to the while loop. So far we haven't done any change to the Boolean flag. So that means it remains to be false. So this negation here will still evaluate to true. So that means we're going to run this one more time. All right, let's be patient here. Let's now continue. Let me use purple here. And this will be 13. You can think about 13 is checking this Boolean condition again, right? And we check that not false is still true. And 14 will be we want to print out to the user enter a radius. That'll be a second prompt. And then we got 15 over here asking the user for a new input. Let's say this time they give us 10. Okay, it's going to be 10 this time. And then we're going to say 16. we're going to create a new circle, and then 17, we go to the try block the second time, and then we got 18, which will be to call the set radius the second time. And this time, the R will be 10. And we know that it's not going to trigger any exception, but let's now step into it. So we got 19. Okay, I'll try to write it here. So 19 will be the if statement here. And we now got we got 10. 10 less than 0, false. So we bypass here. And we go to the else part. So it's going to be 20. We're going to set the radius to be 10. Now, when we resume back to this method call over here, should we go to here or should we go to catch? Here, right? It's not normal. All right? So now it's going to be 21. 21 is very important. It really has to be there to make the whole thing work. 21 says the following. Now that I'm able to reach the next line after this method call that potentially can give me the exception, but because I'm able to reach this line, that means the exception did not occur, so no error. In that case, I'm going to set this invalid input, I'm going to set this Boolean flag to be true. So when I go back to check the while loop header again, not true is going to be false, so I can exit from the loop. That's how things are going to work. All right, let's continue. That'll be 22, and then 23, and we don't really go for the catch block anymore. And then we are now reaching the end of the loop. And finally, 24 is going to be a final check on this Boolean condition. Because we already set the Boolean flag to be true, not true is going to be false. So we're going to exit from the loop. That's it. That's the exact continuous 2 runs of the set radius. The first one did not trigger. The first one triggers our exception. That's why we got to prompt the user for a second time. And the second time, it does not trigger any exception, so we have to exit from the loop. It cannot be infinite. If you more or less follow the idea, that's good, but you really have to dive into the details of this, right? The logic here is pretty clear, but it's also very useful. All right, any question here? Yes?
All of the examples we sort of like specified our own error. If we don't remember, like, know what the error of like some default thing is, like let's say we're trying to set something to a double and it's a type mismatch, but we don't remember what that is. Can we just do like a blanket accept all error type thing?
You mean for the catch block?
Yeah.
Yep. The question was, let's say I got maybe a bunch of method calls over here in the try block, but I somehow kind of forget what kind of exception it might be thrown from some of the methods. Can I simply put maybe catch and put some very general name over here? The quick answer is yes. You could simply have put maybe exception over here. That's like a known class in Java. If you put it there, that means any exception from the try block is going to go into this block. The disadvantage of this is once you reach this point, you don't really know what kind of error it is corresponding to. So in that way, you may have to do some further case analysis to see what they are.
Wouldn't the E variable contain specific errors?
Indeed, but remember this one here is going to be printed to the console already, unless you just want the user to see what kind of error it is. But if somehow you as a programmer, you may want to say programmatically, I want to do something conditional on what kind of error I got. In that case, you cannot do it. You may have to maybe get access to what exactly E contains over here. But that could be a little bit not so convenient. So I think the more, like a better practice would be, you kind of get multiple catch block, which we'll see, to tell you exactly which error might occur and do the corresponding action. That'll be better. Okay, good, but that's a good question. All right, any question about version 2 here? Anyone? Yeah, version 2 is really just, again, strengthening about the catch, about the execution flow for the exception. Let's now take a look at another example here. It will be slightly more complicated. And I would suggest let's do this one more quickly, and then we'll take a short break, and then we can continue. Only a few things left for the exception, okay? Let's now talk about a new example here. Okay, we got three classes involved rather than two. So we got account, we got bank application, right? They kind of related to each other. Right? We got three things. Not too bad. It goes like this. So we start with bank application, and then we create a bank objects. And then we try to call the withdrawal method over here. The 23 here is to say I want to search for the account of ID 23. And then once I have found that account, I'm going to withdraw certain amount from there, and the amount comes from the user input. You can see we also got scanner input, right? The amount comes from the input, right? It could be valid or it can be invalid. So the entry point of execution will be bank application dot withdraw. Oh, sorry, beg your pardon. It will be bank application dot main method. Let me just re-highlight this. So bank application.main, this will be the entry point. And then we got the bank class, and then we're calling the withdrawal method from there. So that will be bank.withdraw. Okay? And let's now, if we go into the context of the bank class over here, the withdrawal method is there. And we got this, so this will not be the caller. What will be the callee? Which will be here. We got another class. Okay, look at this expression here. Okay, I'll write it down here. Counts at index I dot withdraw. This is a withdrawal method, but there are two withdrawal methods in our context. One withdraw here, the other one withdraw here, which is totally fine. It's okay to have the same name of the method in different classes. But now, which withdrawal method are we talking about over here? It depends on the type of the context objects. What will be the type of the context object over here? Right, that's important. Accounts I, right? If you only talk about the accounts, only this one here. Right? This one here, according to the declaration here, accounts is of type account array. An array of accounts. But now I'm saying I want to go to a particular index of the account. So that means it's going to give me a single account. Right? So this tells me that if I say accounts I dot withdraw, is indeed going to refer to this account, withdraw. Right? Depends on the context. On the other hand, when I do b.withdraw over here, because the b here is of type bank, so it will go to this version of the withdraw instead. Again, really depends on the context type. Okay, so we have account dot withdraw. Account dot withdraw. Accounts dot withdraw. And over there, you can see we say that if the amount that we want to withdraw either is less than 0, for example, you cannot say I want to withdraw minus $1 million from an account, right? That should not be allowed. I hope you know why. And then, or you shouldn't really try to withdraw something that's more than your balance. That should not be allowed either. Right? So these are the error condition. If either one of them is true, then we should really throw the exception over here. So now I'm just referring to a new kind of exception, invalid transaction exception. So once you put it in the Eclipse, you will know how to generate it by Eclipse. If no exception, I'm just going to do the withdrawal. Just deduct the balance. All right? Simple class. Any question about the setup over here before we do some simple tracing? I think the only thing that might be a little bit, not really new, but something you want to pay attention to is when you got an array indexing expression like this and make a method call, you really need to know how to know which version of the withdrawal method is being called. Either this one here or this one here. Now I'll just explain how you can identify it. If no more question here, let me do a final tracing on this example, and then we should be good. And the diagram here just shows you how to visualize the object structure. You can go for that, and then when you do your own tracing, you can check against your diagram. Let's say we want the user to enter some invalid value, negative value for withdrawal. Let's now give it a try. What's going to happen? All right, we got 1 here, 2 here, right? Create the account, add the account, standard. We're going to read the input. We're going to declare the scanner. And now number 5, we're going to read some input from the user. Let's say they enter -5 million, right? And then we're going to go into the try block. Number 1, we're going to call the withdrawal over here. And the amount over here is going to be -5 million. We know that it's going to trigger some exception, but let's see exactly how. Number 7, and then we're going to go to the withdrawal method here. And it's going to run the loop somehow. And then number 8. And then it's going to check to see whether the ID is going to match, for example, 23 over here. In this case, we do have the account with matching ID 23. Let's say for the first time, right? Just make it a bit simpler. After that, we're going to go to check to see what's going to happen when we call the withdrawal method. And don't forget, the amount over here is -5 million. -5 million, -5 million. And we're going to go into this withdrawal here, the callee. And then we're going to check to see number 11. Now, -5 million less than 0, true. So number 12. We're going to throw that exception out. Right? The rest of the code is going to be bypassed. And then when we go back to this particular method call, we know that that one there throws an exception. So this one here tells you the invalid transaction exception. Invalid transaction exception thrown. Right? So everything is going to be disrupted. So when we go back to this withdrawal method here, it's going to be propagated to there because we got a throws option from its callee. And we're going to bypass the rest of the try block. That's important to note. And then we're going to have 11 here. We're going to go into the catch block. And then we're going to go into printing out the exception. Pretty much the same as what we said before about the execution flow, but I'm just doing on a different example. What you should really feel comfortable about later is to say, if I give you any arbitrary pieces of code with caller and callee, how can you trace the execution? That's important. All right, any question? Yes? Sure. Okay, good. Good question. So here, I didn't really include it in the tracing kind of intentionally, just not to complicate the matter. So where should it go? So when you actually throw this exception over here, say new, right? That's an anonymous expression. So when you say new invalid transaction exception, you're basically calling this constructor. So if I want to trace further, I could have put, for example, 12, and then this will be 13, for example. That could be the case. But I just didn't choose it. It would be invalid transaction exception. Yeah, so you can see the name here matches the name over here. Mm-hmm. Yeah, again, like what I said last time, don't worry too much about extends and super. They have to do with inheritance. For now, I will not ask you to write anything like that in the test, don't worry. So I would say just know how to create like a exception clock like this, partially automated by using Eclipse for your lab number 2. That'll be enough. What you got to put is make sure you put on string parameter for the overloaded constructor and put a super S, just for now. Okay? The rest I'll explain later. Okay? Okay, good. So why don't we say we take a short break by taking attendance, and then we'll continue with a few more examples. Okay, we still got some time. Okay, please take your mobile device ready, and then I'll do that in 4 minutes. I got 2 more examples over here about exception. I would suggest we do at least, we'll see, maybe at least the first one, okay? And then the last one there wouldn't take long. All right, now this will be related to one of you guys asked the question before the break. Let me show to you. What if the try and catch block, they can be, okay, here goes the syntax. You got a single try block. It can be associated with as many catch blocks as you like, as long as the methods called over there will correspond to the exception being thrown. Okay, what does that mean? You can see here, I'm just reusing the methods that we discussed before the break. So we know that this withdrawal method here, this guy here, let me highlight it. There's one here, may throw the invalid transaction exception. This might be possible, okay? So this may throw the invalid transaction exception, right? So if I try to call that, and of course I got to handle it. In this case, I can use a catch block over here. Similarly, for this one over here, this one, let me highlight it as well. So this will be this one here. It might throw negative radius exception. Negative radius exception may be thrown. The main message from this page over here just show to you the syntax. So with a single try block, you may have as many catch blocks as you like. Each individual catch block should really specify a particular kind of exception, right? Let's now look at one trace, then you will see what I'm talking about. Why don't we do this one here? And then this one here will be exercise for you, okay? Let's do the first one. Let's say I got this one here. All right, let's now say we try to withdraw minus 5 million, and we try to set the radius to be 23. All right, let's see. So we're going to do 1 here, 2 here, 3 here, all good. Initialize the bank objects, and then we try to add an account, fine. We try to deposit, no exception that can be thrown. Now we go to number 7 over here. And in this case, we say the amount over here should be minus 5 million. And we know that it's going to trigger an exception. What's going to happen is the rest of the try block will be bypassed. Now, where should number A be? Should it be here or should it be here? Should be this guy here, because the exception that's being thrown has a specific type. Invalid transaction exception. It's going to go to the matching catch block. So in this case, it's also going to bypass this one here. So we're going to go for number 8, number 9, and number 10. Yes?
So since you have very specific exceptions being tried,
Uh-huh.
are you able to also catch just a general exception?
Yes, you can also write maybe some catch exception, but I would say let's not worry about it just at this moment. Because I think to really discuss that thoroughly, we need to have the notion about inheritance, which not yet. So I would say for now, always you can assume that we got different types of exception that's defined by yourself. In that way, you can just put them in individual catch block. That'll be okay for now. Mm-hmm. Yes?
Of a similar vein,
Mm-hmm.
you have some sort of, I guess, blanket exception,
Mm-hmm.
or something that's more vague. Would there be issues with like
Ordering?
Yeah, the order. Like,
Yes, okay. So if we are assuming that, okay, how about this? The assumption we are making now is this. The customize exceptions only. Meaning that we'll only list the exception like a 1 here and 1 here that we have created separately on our own. In that way, the order of putting this doesn't really matter. Okay? That's something you can take for granted just for now. Order of their catch blocks doesn't matter. And after I cover the topics of inheritance, I'll try to revisit this point over here to say, If you got some exception related by inheritance, then the order might matter. But for now, assume they don't matter. All right, I'll stop here, and then we'll continue from here from Thursday.